Hello everyone, welcome to MG Academy. The next topic in data structure is linked list. Okay, so linked list is a linear data structure. You can write here linear data structure. Okay, it is a linear data structure. So in my previous lectures, we have seen two linear data structures, that is stack and queue. And today we will see next linear data structure, that is linked list. Okay, now starting with the definition. Linked list is a linear data structure. As I have said, like stack and queue, this is also linear data structure. Consisting a collection of nodes. The linked list consists of collection of nodes which together represent a sequence. These nodes together make a sequence. Okay. The elements of linked list are called as nodes. You can write here as elements of linked list are called as nodes. Okay. And this is the representation of a node. A node consists of two fields. The first field is called as a data field and the second field is called as the address field. Okay. So this first field is the data field. So this data field will consist of value, and the value can be of any data type: integer, character, float, any. Okay. So this data field will consist of actual value. Okay. It consists of value, and value can be of any data type: integer, character, float, and any. Okay. And this is the address field. This address field will consist of the address of the next node. So this is a pointer field. This will point to the next node. So this is a pointer field. Address field is nothing but a pointer field. Okay. And this will contain address of the next node. Address of next node. Okay. So this is a node. Node consists of two fields: data field and address field, which is also called as pointer field. Okay. Now let us consider three nodes. Okay. We will consider three nodes. I will show you how the linked list is actually grown. So we consider three nodes. Let me draw it. One, two, and two. And the number of nodes can increase or decrease, that is shrink or grow as per our demand. If you want some more nodes, then you can increase the number of nodes, and if you want to delete some nodes, then you can delete it as per your demand, as per your need. Okay. So these are three nodes. Now we will insert data in these three nodes. So we will first fill up the data field with values 10, 20 and 30. And the next field is the address field. So for inserting this field, we have to first allocate what address to each of the node. So we will write here address. The address of first node is 1000. The address of second node is 2000. And the address of third node is 3000. Okay. So now we have data as well as address. Okay. Now what will be included in this block? This block will consist of address of next node. The next node is 20 and the address of 20 is 2000. So here we will write 1000. And when we will write 2000, this will create a link to the next node. This node will lead you to this node with the help of this address. Okay. For example, if you want to give a message to your friend, you have a message and you want to pass it to your another friend. So for that reason, you should have some address or phone number of that friend. so that you can pass the message to that friend, isn't it? So like similarly, if you want to go from this node to this, you should have an address of the next node. Similarly, if you want to go from this node to this, you should have the address of this last node, isn't it? So we will write here 3000. And after reading this 3000, we will know the next node is 30, isn't it? Now, after 30, there are no nodes, isn't it? So the address field of last node will be null. Okay, so we can write here as null, isn't it? So this is how a linked list is formed. It is a sequence of nodes. See, the collection of nodes creating a sequence, isn't it? Now, if you want to, there is one head node, so that node will be the reference to the first node. Like first node holds the address of second node. Second node holds the address of third node. Similarly, there should be something that will hold the address of first node. So address of first node is 1000. So here there will be a field, node, head node. So this is not a separate node. This node is just a reference to the first node. Okay. So here there will be a head node. And this node will point to the first node. It will contain the address of first node. This head is the reference to the first node. Okay. This is how a linked list is represented. And the elements of linked list are not stored in contiguous memory location. Okay. Which means the nodes can be stored anywhere into the memory. Wherever they will find free space, the nodes will be stored in that position. It is not necessary that the nodes will be stored in adjacent memory location as in array. In array there is contiguous memory location and in linked list non-contiguous. Okay? Understood? Now let us see how the declaration of node takes place. Okay? So we'll consider a node. We know node consists of two fields. First field is the data field and the next field is the address field, which consists of the address of next node. It is a pointer field. Yes, and the data field, it holds the actual value and that value can be of any type. Integer, float, etc. Means it can be of any type, isn't it? So you can see that a single node consists of two types. Two types in one node, isn't it? So for declaration of node, we require a data type that can accept multiple elements of different data type, isn't it? And in data structure, there is a user-defined data type, that is structure, which can accept multiple elements of different data type. So with the help of structure, we will declare a node. Okay. So for that, we can write struct node. Struct is the keyword and node is the name of data type. Okay. Now the members of this structure. So you can see a node consists of two fields. Therefore, here there will be two members. The first one is integer data. For example, if we are storing integer value in this node, 10, 20, 30, like these values we are storing in, suppose. So we will take integer data type. Okay. Now the next is a pointer. So for that reason we want a pointer, isn't it? So we can write here as struct node pointer next. So this next is the name of pointer. You can take any, like link, whatever. Okay. So these are the two members of this structure. Now you might be thinking why I have took struct node, isn't it? So consider integer pointer p. Now what does it mean that this is a pointer? So pointer p will hold address of integer variable, isn't it? Similarly, float pointer f. What does it mean? That f will store address of a floating variable, isn't it? Now similarly here, next. Now next is a pointer which will hold address of the another node, isn't it? There is one node. After this there will be one more node, suppose, and then the address field of this node will consist of the address of the next node, isn't it? So this next will hold address of another node, isn't it? So hence the data type is struct node. This complete is a data type. Struct node is a data type. Okay? And then, so this is how the declaration of a node takes place. Okay? Now let us see what are the advantages and disadvantages of linked list. So starting with the advantages, the first one is linked list is dynamic in nature. Dynamic means the memory is allocated at runtime, and if memory is allocated at runtime, there is no limitation for allocation. We can allocate memory as per our requirement. Okay, so this is the first advantage. The second is insertion and deletion is easier. In linked list, inserting a node into the linked list or deleting a node from linked list is easier. For example, consider this. Consider there are three nodes. Okay, like this, elements, address, the address, okay. Now this node will consist of address of the next node, that is 2000. This node will contain address of next node, and here there will be null. Okay, so there are three nodes, and now we want to insert another node into this linked list. So consider this node. Suppose this is a node 5 and we want to insert it into this linked list after this node 10. So what we have to do, we simply have to write here the address of this node is suppose 4000. Okay, so we simply have to write here instead of 2000 4000, so that this node will point to this. So here we can write 4000. We will remove 2000 from here and we'll write 4000. And now this node will not point here. This node will point here. And this node will consist of address of this node, that is 2000. And now this node will point here. So in this way, a node can be easily inserted into this linked list, isn't it? So insertion and deletion is easier. Third is efficient memory utilization. It means no need to pre-allocate memory. Like in array, first we have to mention the size of array, isn't it? In array we write here as integer a of 50. Okay, so here we are giving the size of array, like in advance we are initializing its size. So with linked list there is no such need of pre-allocate memory. The fourth is linear data structure like stack and queue can be easily implemented. Various linear data structures like stack and queue, they can be easily implemented using linked list. Okay, now the disadvantages of linked list. The first disadvantage is pointer require extra memory for storage. We know a structure of node, it consists of data field as well as address field, and this address field consists of pointer to the next node, isn't it? So for every node there are two fields. So along with the data there is one more field which is pointing to the next node. So this field is a total wastage of memory. This field is responsible for extra memory and therefore memory wastages occur. The second is no random access. We cannot access the nodes of linked list randomly. For example, if we want to access this node, this last node, so we cannot directly, access this node. We have to follow sequence. First, with the help of the head, which will contain the reference to the first node, we can access this node. After this, this. After this node. And finally, the node which we want to access. So for accessing the last node, we have to also go through the other nodes, isn't it? So there is no random access. There is sequential access. So this is one more disadvantage. In case of array, if there is an array of 5 elements, for example, 1, 2, 3, 4, 5. And if we want to access 3, so we can easily reach out 3 with the help of the base address, isn't it? But in linked list, we have to follow the entire link to reach the required node. Third is reverse traversing is difficult. We cannot reverse traverse easily. Backtracking is difficult. See, it is easy to go from year to year, but if we want to backtrack like from 30 to 20, then 10, so this is very difficult. So backtracking is difficult. Even if it is a doubly linked list, in that case also reverse traversing is difficult, because in doubly linked list the structure of node is somewhat like this, isn't it? There are 3 fields in the node. This is for previous node, this field will point to the previous node, this field will point to the next node, and this field will contain the data. So again, this pointer field we have to waste extra memory. So reverse traversing is difficult in linked list. So these are the various advantages and disadvantages of linked list. Okay. So that's it for today. Hope you understood my today's lecture, and if so, then give this video a big thumbs up, subscribe to my channel and share it with your friends.